Dear students, yesterday I have discussed about the question and answer session in the boron family. The first question is structure of boron is. Today I am going to reveal the answer and I want to give the appropriate explanation. Structure of boron is option A octahedral, option B tetrahedral, option C icosahedral, option D tetragonal. So, boron, generally the fundamental building block of boron structure is made up of 12 boron atoms. So 12 boron atoms. These 12 boron atoms which are present on the 12 corners of the structure. So here this is the structure of fundamental building block of boron, and the structure name is icosahedral. In that 12 corners and 20 faces are present in the icosahedral structure. So here the question may be structure of the boron, or how many number of corners are present, or how many number of faces are present in the icosahedral structure. So any type of question is possible to ask in the JEE and NEET. So this is the icosahedral structure. Icosahedral structure. Icosahedral structure. So icosahedral, the option C is the correct answer for the first question, structure of boron. Okay, next question. Boron reacts with carbon to give. Here the question is that boron oxide, not boron, boron oxide reacts with carbon to give option A BC3, option B B4C, option C B2C, option D BC. So to analyze the answer for that question, we have to see that what are the chemical reactions undergoes the boron. So B2O3, when it reacts with carbon, it forms that B4C. It forms that B4C along with carbon monoxide. So to balance the equation, you can take that 2B2O3 and 7, then it makes that 6CO and B4C. So the correct answer is, you can see the options. Option B is the correct answer for the boron oxide reacts with carbon to give that B4C. So along with that, some other important equations are there for the boron. So boron reacts with oxygen. Boron reacts with oxygen to give that B2O3. This is called boron oxide, and here the equation can be balanced by taking 4B and 3O2. You can see that 2B2O3. And another reaction, boron, when it reacts with nitrogen, it gives that boron nitride. So here you can take that 2B and 2Bn. So this is the boron oxide, and this is the boron nitride. Boron also reacts with concentrated acids. It gives that boric acid. So the formula for the boric acid is H3BO3. So boric acid. And boron does not react with dilute acids. No reaction. no reaction. And boron reacts with halogens. Boron reacts with halogens to provide that boron trihalides. Boron 3B. So here BF3, 2BF3, and here 2B. So these are the some other important boron chemical reactions. So now we will go to the another question. Third question, compound A reacts with lithium aluminum hydride to give two compounds B and C along with lithium fluoride. And compound A, B and C respectively. If we see that option A is hydrogen fluoride, hydrogen and AlF3 is there, and B is boron trifluoride, hydrogen and AlF3. Option C BF3, diboron and AlF3. Option D P2H6, BF3 and AlF3. So the question is that A reacts with lithium aluminum hydride. A reacts with lithium aluminum hydride to give B and C along with boron trihalides. Boron 3B. So here BF3, 2BF3, and here 2B. So these are the some other important boron chemical reactions. So now we will go to the another question. Third question, compound A reacts with lithium aluminum hydride to give two compounds B and C along with lithium fluoride. And compound A, B and C respectively. If we see that option A is hydrogen fluoride, hydrogen and AlF3 is there, and B is boron trifluoride, hydrogen and AlF3. Option C BF3, diboron and AlF3. Option D P2H6, BF3 and AlF3. So the question is that A reacts with lithium aluminum hydride. A reacts with lithium aluminum hydride to give B and C along with lithium fluoride. So here you can see that boron trifluoride, when it reacts with lithium aluminum hydride, it gives that diboron plus AlF3 plus lithium fluoride. So here A is the BF3, B is the diboron, and C is the aluminum trifluoride. So you can observe that option C, A is the BF3, B is diboron, and C is the aluminum trifluoride. So this is the C, option C is the correct answer. The fourth question, which of the following oxidation states are most characteristics for lead and tin respectively? Option A +2, option B +4, option C +2, option D +4. So if we observe that question, the most characteristics for lead and tin. Oxidation state for most characteristics for the lead and tin. So lead and tin, they are belongs to fourth group, 14th group. So the general electronic configuration for 14th group is ns2 np2. So when general electronic configuration is ns2 np2, the outermost whatever the electrons are there, when the electrons lost, it gives that oxidation state. How many number of electrons are moving, so that many charge it gives, that much charge it gives. So when it is lost 4 electrons, generally the group will get that most characteristics will be +4 oxidation state. So this is for all the 14th group elements, general electronic configuration, and most characteristic will be +4. But carbon, silicon, germanium, stannous, lead. Carbon, silicon, germanium, stannous, lead, they are the 14th group elements. When in the group from top to bottom, when we are moving, what happens? When the size increases, in the lead, what happens? There are d orbital, f orbital also present in the lead. So because of the poor shielding, what is meaning by poor shielding? The from the nucleus outermost shell which is not covered properly, so that is called poor shielding. If it is covered fully, that is called shielding. So because of the poor shielding, what happens? The outermost electrons which are attracted by the nucleus, when it is attracted by the nucleus, what happens? The lead, general outermost electronic configuration for the lead is Xe, 4f14, 3d10, 6s2, 6p2. So here in the lead, what happens? It plays this s orbital 2 electrons which are not ready to share the electrons to form the chemical bond. That is called the s electrons, 6s orbital 2 electrons which are not ready to involve in the formation of the chemical bond, so they are inert. Because of that, lead can show that stable electronic configuration only +2, not +4. So the lead can show that +2, and generally stannous or tin which can show that +4, obviously, which is the 14th group element. So the lead +2 and tin +4 oxidation state is the most characteristic oxidation state for the elements. Okay, option C is the correct answer. Next, the last question: which of the following species is not stable? Which of the following species is not stable? Here you can see that SiF6 2-, GeCl6 2-, SnOH6 2-, SiCl6 2-. Generally germanium and stannous, they are the heavier metals and they can form that octahedral complexes. But when we observe that silicon, there is a silicon hexafluoride is there and silicon hexachloride is there. So silicon, carbon, after that silicon is present in that same group. So carbon can form only at excited state, carbon electronic configuration will be 2s1 and 2p3. So it can form maximum 4 bonds. So the covalency of the carbon is 4. And silicon, there is a 3s1, 3p, 3 will be there, and after that there is a 3d orbital also, a vacant 3d orbital also present, 3p3 and 3d, 0 is there. So here by using that two vacant d orbitals, it can form that SiF6 and the hybridization will be sp3d2 because of one s orbital, 3 p orbitals and 2 d orbitals involved in the hybridization. That's why it is called sp3d2 hybridization. And there is a orbital size is same silicon and fluorine, and chlorine is the larger in size and the electronegativity is smaller, electronegativity is less compared to fluorine, so that the SiCl6 is a not stable compound when you compare to the among those three. So option D is the correct answer. So I hope you understood. If you understand, you like my video, share and subscribe. Next video again we will meet. Thank you.